Hey students, how are we doing today? Good, I'm good too. Thanks for asking, everyone. Thank you. It's always nice to be greeted. Okay, so today we're going to do lesson 3 in R, and this is going to be an important one. We're finally going to start making graphs of our data, and this is exactly the kind of stuff you're going to need for your semester project. So it might help you to look at this video again later. So lesson 3, and lesson 3 is on visualizing data. And in this lesson, we're going to learn how to make some basic graphs. And let's recall that we can have two types of data. We can have categorical data or numerical data. And categorical data is going to require a different set of graphs than numerical data. And again, categorical data were things like colors or favorite pets, or usually categories, words, things where it doesn't make sense to say take the average. The average favorite pet of J. Sarah students is cat, dog. Right? Doesn't make any sense. But, the average test score, some new numerical data like test scores, for instance, yeah, that does make sense to actually have, take an average of, for instance. So we're going to have different graphs for each. All right, so for categorical data, so the first lesson we're just looking at one variable. And there's not a ton of options for categorical data in just one variable. But pretty much the options we're going to be looking at are pie charts and bar charts. So suppose we had, as before, the list of pets, which was from a sample of 20 people's favorite pet. We had 6 people liked dogs, 11 people who liked cats, 2 people liked fish, and 1 person liked reptiles. Alright, so let's see how to make a pie chart, a basic pie chart here. And the function for pie chart is going to be just pi parentheses. And what you see here, what I did inside the pi parentheses for this first line of code is actually put a vector, the list 6, 11, 2, 1. Well, where'd those numbers come from? That was the 6 people who like dogs, the 11 people who like cats, the 2 people who liked fish, and the 1 person who liked reptiles. So let's just see a very, very basic pie chart here. Again, I just put a list directly into the parentheses of the pie function. And ta-da! Isn't it beautiful? Okay. No, I didn't think it was that beautiful either. But here it is, at least, as a basic pie chart. And you see here, it says the number 1, number 2, 3, and 4. And where do these numbers come from? Well, this is 6. Number 1 was 6. Number 2 was 11. Number 3 was 2. And number 4 was 1. And that's just the order I put it in. But as you can tell with that, it's horribly boring. We all know we're supposed to label stuff. So a better way of doing this is, instead of using the, let's say, just putting the pi of the vector there, let's store the vector. So I just called this vector p now. So p was the list 6, 11, 2, 1. Again, if you're not sure, it seemed like nothing happened, but hit p and enter again, and there it is. And then if I just do pi of p, of course, I should have the same exact graph I had before. It's just the pie chart of the same list that we physically wrote in there before. Okay, so we definitely noticed that, hey, what's up with this pie chart? I don't know what category is what. It looks kind of boring. It doesn't have a title. It doesn't have percentages or anything like that. So let's look at a couple alternate ways of actually making a pie chart. So what I did here with this list P was just put the frequencies of each category in my list P. However, maybe I could have stored my data a little bit differently here. So let's say instead of the actual frequencies, let's see what I did here in this list here. So I'm creating a new vector called pets, and I'm repeating the word dog 6 times, and then I'm repeating the word cat 11 times, and repeating the word fish 2 times, and repeating, or I actually didn't repeat, I just put reptile in once because there was only one reptile. So let's see what happened to this list pets. Well, there it is. There's the 6 dogs, 11 cats, 2 fish, and 1 reptile. Are you impressed? I'm not that impressed either. So let's see here. If we use the table function, we could see just how many pets we had. Of course, we already know how many pets we had, but this is just to confirm. 11 cats, 6 dog, 2 fish, and 1 reptile. I want you to pay attention to something. How did these numbers come out? When I hit table pets, you see cat came first, but remember the dog actually came first. Then dog, fish, reptile. This example is a little confusing because we kind of look at this and go, it must be in terms of decreasing frequencies since there were 11 cats there first, right? No. It's actually in alphabetical order here with respect to the categories. It just happened to work out this way in alphabetical order that 11 people liked, that cats came first and 11 people liked cats. Well, it's my example, and as you just heard, I like cats. And as you're still hearing, they're a little frisky right now. All right, so what's nice about me just hitting this table function? Well, what's nice about just the table function is that if you see here, in this case, the way I had this list stored, pets, as the actual just physical words, what's nice about this is that when I hit this table, it not only gives me the name of the categories, but the frequency. So watch this. Number one, if I just do pi of pets, it's going to actually give me an error. Why? Because it says the error in pi pets, x must be positive. That x values must be positive. That really is saying I want numeric numbers in here. I can't take a pie chart of categorical data. But look at this. I just made a frequency table using the table function. So instead of doing pi of pets, what if I did pi of the table of pets? Watch this, you're going to be so impressed. Where'd that go? Yay! Look at that. So not only should this be correct, because we had 11 cats, I believe out of 18 total, so that's a little over 50%. We see the cat category takes over 50% of the pie chart, so that's good. And then the dog category came next, and fish and reptile. And notice how these are now spelled out for you. And why was that? Well, remember when we used that list P, I just had the numbers 6, 11, 2, and 1. But now using this table, it actually assigns names to it. So that's pretty nice, right? Aren't you impressed? Now I don't have to actually write cat, dog, fish, reptile. So besides just making pie charts, I can also make a bar chart out of this. And the function for bar charts is bar plot. So let's look at a very, very basic bar plot. Let me do this again. Let's do an error real quick. Bar plot. Again, let's say I had that list pets, and again, this list pets had all the words dogs and cats in there. We got an error. Why again? This is non-numeric. It actually wants a numerical value in there. So I have two options. I can use that list P that I had stored up here. That's just the number 6, 11, 2, and 1. Let's see what happens. Ooh, fancy. It's not that fancy yet. Or better yet, what if I did what I did before and had the table of the word pets? And hopefully this time they're going to put some names to my categories. Yay, indeed. Hooray. So we do notice this is in descending order, but that just happened coincidentally. The only reason why that happened, that the categories are in descending order in respect to frequencies, is that really it's putting this in alphabetical order. So there's an alternate way of doing this. Can you imagine if you actually did this sample? Would you really want to go out and write, even, what did I do here? This list here, repeat dog 6 times, repeat cat 11 times, repeat fish 2 times, repeat reptile once. No, there is an easier way to do it, and that's using our frequencies here. So if I knew, if I did have this list, P, which was the frequency of each category, watch this. I can actually name the categories. So if I do names of P, YP, I'm naming this list. And then I have to use the C function now because I'm going to have to make a list of 4 different names for each category. Now with respect to order, the first category was dog. That's going to be assigned to the 6. The next category was cat. That's going to be assigned to the 11. And then fish, that's going to be assigned to the 2. And then reptile, that is going to be assigned to that last number 1. And if I hit enter, again it looks like nothing happened, but now let's see what happens after I hit P. Not only does it have the number 6, 11, 2, and 1, but now it's got names attached to each. So now what's going to happen if I look at my bar plot of my list P? Hopefully it's going to have all those names in it again. Good, and this time it does. Now again, let's see which order is this in. This is in exactly the order that I put my list in. So that's dog, cat, fish, reptile. Dog, cat, fish, reptile. So that is a pretty basic, or lastly, I'm sorry, then we'll get to 3.2. Lastly, Pareto charts. So Pareto charts are, like the first time we did this, are just bar charts where the categories are arranged in descending order with respect to frequency of each category. So it's always, it looks skewed right, but don't use the word skewed right to describe a Pareto chart. Why? Because they're categorical data. All I have to do is, put them in this order and it's not skewed right anymore. Maybe it's a little bit more mound-shaped. So how can I take this same chart here using my list P and turn this into a Pareto chart? Well, I can use the sort function. So let's see what I'm doing here. I'm taking the bar plot of the sorted list P now. I want you to see what happens when I just hit enter. Ta-da! Oh, wait a minute. That's the wrong way. Well, it's sorted, but it's sorted in ascending order instead of descending or decreasing order. So what we can do here, we learned this last time, is inside the sort function, we can put decrease equals true, or a shortcut. You can write it, you could write the word decreasing and then equals in all caps true, or a little shortcut for that is going to be DECR for decreasing equals capital T for true. And hopefully I'm right. Phew, I am. And when you do that, you could see that now instead of ascending order, it's in descending order, and this is a Pareto chart. A basic Pareto chart. But, so moving on to section 3.2, if you were in my class right now, you would know that I really demand everything be labeled. Why everything be labeled? Because the idea is that any reader could just come to this chart and read it and figure out exactly what's going on. Looking at this chart, I don't know what's going on. I just know that there's some cats and dogs and fish and reptile. I don't know if these are people's favorite pets or if these are just the animals I saw as I was walking down the street. Nobody knows, so we need to do some labeling. Let's actually go to our pie chart. So there's this help function, and I believe I showed you the help function before, but the help functions are particularly handy with graphs. So if I do help and then pie, what I'm actually asking for is help for the pie function, which makes the pie. And this is when these charts, this help function is going to be more and more helpful. Because if you can see here, let's see if I can maybe zoom in if this is on the TV. So it says, pi, x is going to be just our list, and it tells you what x is, a vector of non-negative numerical quantities. So this again says that it wants positive numbers and not categories. Labels, names of x, what that means is, remember how when I hit the pi function and after I actually stored the names, it's going to use those names that I stored as the labels. Well, that's nice, and that's just going to happen by default. Edge is 200, radius equals 0.08. These are all, so when it has these are all default. That is, by default, I didn't change any of these numbers, so this has a edge of 200 and a radius of 0.8, whatever that means. Clockwise equals false. I'm assuming that means that these categories are going to go in counterclockwise order of which way I gave them and which way I entered them, and that looks to be true. So I could change that if I wanted to. Let's actually change that. Let's try it. The argument was clockwise equals false. So that means by default clockwise is false. So if we want to change this, clockwise equals true. I haven't hit enter yet because I just want to remember what order this is in. So this is the counterclockwise order. Let's see. And you can see it changed. Yeah, it did change directions. It went clockwise, cat, dog, fish, reptile, instead of dog, cat, fish, reptile, which is the order it went in before. So that's nice. Let's see what else. I don't even know what all these mean necessarily. I'm not sure what this is. Density is null, angle is 45, color is null, we'll get to that one. COL stands color, we'll get to that. Border equals null, I've never changed that. LTY, actually no LTY, that's line type. Line type, if you want like a dash line instead, you can change that to like LTY equals 1. Yeah, let's try it, why not? Let's add that one. LTY equals 1. That should give me some dash lines somewhere. I don't see them. I didn't really think that did much. But you'll see with histograms and some other ones functions that this help function is extremely useful, and this gives you every single argument that the pie chart uses. Now this ... means there's actually more, and we'll see some of those later. Okay, so back to the lesson. Where did the lesson go? Okay, so to add a title, this didn't show up in there, which is probably why it had the ... We're going to use the function main equals, and this works for every single graph that we're learning here. If I want a title, I'm going to put main. You could think that means like main title equals, and then go ahead and put in a title. Student's favorite pet. And let's see what happened. Ta-da, there it is. There's our title. Student's favorite pet. All right, now this is starting to take a little more shape, right? It's starting to mean a little bit more. You can also do a subtitle. And for a subtitle, you can use the function sub, or the argument, excuse me, sub. So if I say something like in this case, maybe since I sampled 20 people, I'll put sub equals, and then in quotation marks, n equals 20. Anytime you do a title, make sure the whole thing's under quotation marks. It's going to be true for main titles, subtitles, labeling x-axes, y-axes, and pretty much everything else. So you see here, that's kind of nice. Down here it says n equals 20, and that lets the reader know that I had a sample of 20 students. Ooh, exciting favorite pets, right? Okay, so how do I change the color? So these are some default colors. They automatically came up. They're not bad. There's a few ways to change the color. And R has a bunch of colors stored. Now the colors can either be in terms of names or integers. So since I have 4 colors right now, if I do call for colors equals 1:4, what I'm saying 1 through 4, use the colors with the numbers 1, 2, 3, 4. And if I do that, you can see at least what the first 4 colors are. Alright, it looks kind of funny, but hey, that's like a nice just pure red, green, blue, and black. So that's kind of nice, but, well, it's nice having color, but the colors are kind of hideous. So, you might be asking, well, can't I use different colors? That's a good question. I'm glad you asked it. You didn't ask it. That's okay. So in today's handout, I attached a PDF file called R Colors. And that's this guy, and it's insanely a little bit hard to read, but if you zoom in a little bit, I'll go to 400%, you can actually see all these colors here. Aquamarine, Aquamarine 1, Aquamarine 2, Aquamarine 3, Aquamarine 4, Azure, or is that just the Italian way of saying it? Oh, here's a nice one, Corn Silk. Ooh, such lovely color names. Coral. All right. Deep Sky Blue. Ooh, Corn Silk. Cyan. Dark Goldenrod 1. Ooh, Firebrick. Floral White. Ooh, this is some fun names, right? There's a Dodger Blue somewhere for all you Dodger fans. Here they are, Dodger Blue. Sorry, Dodger fans. It's too bad there's no Cubs Blue. Oh, too soon. Sorry, too soon. Rosy Brown. There's a color for you, Rosy Brown. Orange Red. Orange Red 1, Orange Red 2, Orange Red 3. Salmon. All right, Sandy Brown. Tomato. Tomato 1, Tomato 2, Tomato 3, Tomato 4. Turquoise. There's some just fun colors in here, isn't there? You can play around with this for quite some time. So, how do you get to use the colors of your choice? Well, let's go back to this same code here, and so I want to use 4 colors. So to use 4 colors, I'm going to have a list of 4 colors. So I have call equals, and here's my vector function, my C function. And then in quotations, we're going to use our colors, and we can use them by name. So Dodger Blue, for instance. Maybe that's my first color. Tomato 2. Maybe I want to use Tomato 2. That was a great color. Floral White. And maybe my last color will be, what was a good color on here? Oh, yeah, good one. Sandy Brown. No, sea green? Okay, sea green 2. How about sea green 2? Sea green 2. And as long as I spelled them all right, which it looks like I did, all those colors should come up. So I'm assuming this was the tomato. Here's the Dodger Blue, Tomato, Floral White, and that's sea green 2. A little better than what we had before. There's a couple colors of tomato, so maybe I'm going to just change this to Tomato 4. That was a fun looking shade of tomato. Alright, see, it's like those purple tomatoes. You know the ones I'm talking about? Yeah, you know the ones I'm talking about. Let's see, and you can see here on this example, you could do the same thing with the bar plots as well. In this example, in the lesson, it looks like I used Dodger Blue, Dark Salmon, Orchid, and Gold. So besides the pie chart, we could do this with any chart we want. So I'm going to take this, literally the same set of code, and watch me just change the word pie to bar plot, just to make a bar plot using the same colors here. Ooh, isn't that nice? Yeah, you're welcome. Yeah, I said you're welcome. And we'll see some more little tricks to customize our graphs in a little bit. Okay, so let's get on to 3.3. Let's look at numerical data. So again, those were the two main types of graphs for categorical data, the bar charts and the pie charts. Again, we're only looking at one variable. We'll do another lesson later comparing two variables. Okay, so what we got for numerical data, we can use stem plots, histograms, box plots, and dot plots. So we're going to look at those. So let's store some lists here. I'm just going to copy and paste all these. So this first one was heights, and this was heights from some random students. And the second one, sec, is going to be the seconds that it took some people to run the 100-yard dash. So let's just load those into R so it stores them. So I just copied, pasted. There they go, no problems. And let's see stem plots. Stem plots are quick and easy, not much to them. But if you want to do a stem plot, say, of all those heights, we could do, of the list of those heights, I'll do stem plots, stem heights, and there's the stem plot of the heights. So this was the 59, person who was 59, this was 61, 63, 64 inches. Looks like it automatically split the stems for you. If you see here, it automatically did that, as I said. So it took this is would be 55 through 59. These would be the values 60 through 64. This is going to be 65 through 69. And this is going to be 70 through 74. And it even gives you a little key here. The decimal point is one digit to the right of the... The decimal point is one digit to the right. So this is one digit. The decimal point would be right after this 9, so 59.0 in this case. Well, what about those decimal places? Let's see what happens if we do a stem of the seconds, because if you see the times it took these people to run the 100-yard dash, we do have decimal points here, so let's see what happens here. And you can see here, this says now the decimal point is at the... Just checking something. It looks like it actually rounded these. That's interesting. I didn't know that. So this is actually 10.8. This is another 10.8. That's a 10.9. This is an 11.0, 11.2, 11.2, 11.3, 11.3, 11.4, etc., etc. So if I'm actually look at the original list, I can actually tell that it looks like it rounded to the nearest 10th digit. Okay, so that was the stem plots. Nothing too exciting, but still a little bit exciting, right? Yeah, I thought so. All right, what about box plots? Box plots, just use the box plot function like before. Well, like bar chart, bar plot, we could use box plot. And here, again, this has to be numeric data, so let's look at the box plot of the heights of those students. That, or maybe not. So here is the box plot of the students' heights. Now if you notice the way it came out, to me it came out really wide, really kind of funny looking to me. So what you can do actually is just drag it, and you can kind of drag to the size that you feel is best for your box plot. So you're probably saying to yourself, wow, this box plot looks really boring. First of all, it's probably not what we're used to. It's vertically aligned as opposed to horizontally aligned, which maybe we've only seen up to this point. Nothing wrong with that. And we could see this, just this Y label just goes 60, 65, 70. But these are going to be the heights of the students. Remember, this is the minimum value, the whisker at the bottom. The whisker in the Q1 is right here at 65. The dark bar in the middle is the median. Q3 is right at 70, and it looks like the max is about 74. So let's see, how can we spice this up? Well, we could start with, like before, we could start with the title. So if I go box plot heights, and again inside the parentheses of the box plot function, maybe I want a title, and maybe this is heights of my classmates. I feel like the word "my" should be capitalized here too, right? So, let's see how that went. Went okay. It was a long title, so maybe if I drag this out a little bit better, it'll position itself a little bit nicer. So if you don't like it vertically aligned, I don't like it terribly vertically aligned either, so we can change that. And what we can use is the function horizontal. We can do adding this here, and I'm going to add horizontal. By default, it looks like it goes vertical, and if I do horizontal equals true, hopefully it doesn't yell at me. It looks like it didn't. Going back to my bar chart here, I could see now instead of being vertically aligned, it's horizontally aligned. And again, now it's kind of nice to kind of drag it. I can drag this around to kind of maybe get the shape that I want, because by default it could look a little funny, right? So just drag those corners to really position these. So let's see what happens with this with the seconds. The seconds again was the time it took to run the 100-meter dash, 100-yard dash, that is. So it looks like this is still vertically aligned because we didn't put that in. Oh, what's that little dot up there? What is that? Oh, it's an outlier. Using the 1.5 IQR rule, it looks like we have an outlier in this data set. So it's kind of nice to know that R will automatically find these outliers and display them with a dot. I'm going to be honest, these open circles just kill me. I just don't like these open circles. So if you want to change it, you can use the option PCH. It stands for Pacific Coast Highway. No, I think it stands for point character. Point character, like if I'm making a dot or a point, and it's got a bunch of these point characters stored up. And if you want to try to mess around and see what they are by number, my favorite is number 19. And if I do PCH 19, I say it's my favorite just because it's just a solid dot. You know, you want to see what else is out there? We'll try putting in another number, PCH, I don't know, 11. Let's see what happens. Let's see what happens to that dot. It's wow, it's like a Star of David. In fact, if you do a quick internet search, you can find all these these characters in R. First of all, if you do R colors, say something like that, I mean, right away, you could see I found exactly the same document, the same picture that I gave you. If you want, say, those point characters, PCH, try RPCH. I mean, internet knows everything, right? R plot PCH symbols. Let's see what happens. So, look, there was that 11 that I used. There is 19. It looks like actually PCH 20 is a smaller dot than PCH 19, which is the one I tend to use. And you can actually, that's right, I forgot, if you want to go crazy, you could use these numbers, or, you guys don't want to go crazy, do you? Watch what happens if I put a character in parentheses, like, I don't know, maybe the @ symbol. Ooh, we went crazy, you see that? Calm down now, calm down everyone. That's how crazy we can get in computer programming. Maybe you didn't like that, maybe, I'm just curious, what happens if I put the whole word outlier? I don't know if you saw, I just put PCH quotation marks outlier. No, I thought so. It only took the O, took the first letter, because it's literally point character. It's just one character. Okay, so we can add some color here as well. Let's see here. So going back to this box plot, I have the title on there, and it looks like I used the color light blue. Let's see what happens if I add the that command call equals light blue. Put some color on it. Oh, that's nice. Maybe I still want to do the same thing. What's always nice, so watch what we do here. If we want to edit our graph or add on to it, I just hit the up button and I get the last command that I use, and now I can add on to it. For instance, I want to maybe add on, in this case, maybe I didn't like how it was vertical. Maybe I want to do horizontal. This should work. I could, instead of writing horizontal equals true, I think I can do horiz equals t. Nope, I can't. I remember struggling with that actually earlier. I thought I could. Horizontal equals, let's just write it all out, true. Okay, now it's horizontal. See, isn't that a little bit nicer? But wait a minute, what's it missing? What? Oh yeah, why is the x-axis not labeled? I don't know, what units were in here, right? 11.0 years? How long does it take somebody to run 100 yards? We're going to do that in part 2. Last part here, and then we'll learn how to label all our axes, like which is all that we're missing right now. How do we make histograms? Well, histogram is just going to be the function IHST, hist. For instance, if I want to do a histogram of the heights of the classmates, let's just try the basic histogram function, hist parentheses heights. Let's see what we got. Hey, this looks a little nicer. There's stuff I didn't do. What didn't I do? I didn't write this word frequency. It automatically figured that out. It also has the word heights down here. And that's the only reason why this says heights is purely because the name of the vector that we used was heights. Otherwise, it wouldn't know what's what. So this is how we make a histogram. And we can add some color to it too, as well as a title. I'm going to kind of skip to the chase here. But you could see this last line of code, histogram heights, the main equals heights of my classmate, and I'm going back to Dodger Blue. Sorry, Dodger fans. And that's a little nicer. We're going to talk in just a minute how to put a label down here, because we need something like inches, something to let the reader know we're dealing in inches here. And also, I'm going to show you how to change the class width. One thing with the histograms is you could see that R automatically just created the classes for me. So this class, I can hardly even tell what's what. Looks like the class width here from 65 to 70 spans 2.5 classes. So I'm assuming, yeah, the class width is 2. That is, this is from 64 to 66, 66 to 68, 68 to 70, 70 to 72. We'll see in a little bit how to change that if we so want to. Okay, so how do we add those labels to the x-axis and the y-axis if we want to change it? Well, it's going to be the function xlab for xlabel and ylab for ylabel. So let's add on to this. So the xlab, the xlabel, And again, make sure all your titles, your labels are in parentheses, and maybe I'll put something like heights in inches. That way we know the units. The Y label, it automatically said frequency for us, which is nice, but maybe I want to change that. Maybe I want to change it to something like number of classmates. That works as well. Frequency is just fine, but I'm just showing you how to do this for emphasis. And you could say, hey, this is starting to actually really look like a nice histogram. Heights of my classmates, x-axis down here, heights in inches, and then here it says the number of my classmates. That's wonderful. So let's talk about how to change this class width. So as I mentioned, the class width in this case, R automatically just did it for us. I think it automatically tries to split it into like 6 to 8 classes, but maybe we don't want to use the predetermined classes. Well, we're going to use this function breaks. Sorry, it's not a function. We're going to use the attribute breaks inside our histogram function. And we're going to tell it where the breaks for every class are. And the easiest way to do that is just to use a sequence. So if I look here, it looks like my histogram started about 55, say. Actually, sorry, 58. It starts here at 58, and it looks like it goes to 74. So maybe instead of using the the class width of 2, what if I wanted to do it by ones? Then there should be a class for every integer. So there should be a class of 50 at 58 to 58.9999, and then one at 59 to 59.99. Well, let's see how to do this. I'm going to pull up my last function. I'm going to add another comma, and then I'm going to do breaks equals. Now I'm going to have a sequence. This is going to tell me exactly where the breaks are. We went down from 58, and it looks like it went up to, let's say, 75. And then if I put a comma 1, it's going to count by ones. So that's going to be my class width. Let me put it this way. When I put this 1 right here, that's going to end up being the width of my class. And now look how this graph changed. Instead of those class widths of 2, which was automatically formatted, I used class widths of 1. So you can even see, for instance, it looks like there was only one person here at about 68 inches. Pretty cool, right? Excited? Or looks like in this example I used the class width of 3. So I had to just be a little careful in this example. I had to be a little careful to make sure with that sequence function that I ended up. So if I went from 58, add 3, 61, 64, 67, 70, 73, 76. I wanted to just make sure I stopped at in this case, a multiple of 3. Or it's not a multiple of 3, but within 3 units of my starting. A multiple of 3 from where I started. Right. So, yeah, I kind of lost a lot of shape, a lot of information when actually using class widths of 3. But hey, now you know how to do it. Woo! So these functions, okay, a few more we could do with the histograms. Now let's just go back without doing the breaks. So I'm copying this code right now, and this is just using before we manipulated the breaks. One kind of cool thing we can do is, in case you're not good at counting, or this actually works really well if you have like some big numbers, if you add the argument labels equals true into our code for our histogram, now what's kind of neat is it puts the frequency on top of every class. Ah, wait a minute, it kind of did, didn't it? Notice how this is missing right here? Why is this one missing? Well, it looks like there were 8, maybe 7 people in that class, but look at the y-axis here, kind of stops at 7, and it really didn't give this any room. So what we can actually do here is if we so want. So again, we look here at the y-axis stops at 7. It might be nice if it went up maybe 1 or 2 more units. Maybe it stopped at 9 instead of 7. Well, let's go back here, and I can add the argument. I can control the window on my x and y axis using x limits and y limits. So I'm going to do y lim. Y lim, I'm going to control my y axis. And I'm going to need 2 points, a starting point and a stop point, so I have to use my c function as a list of 2 numbers. So I'm going to do y lim equals c 0, comma 9. And what that's going to do now is that's going to change, should bring my x-axis all the way up, sorry, y-axis, which started, which automatically before by default stopped at 7. Now it's actually stopping at 9, and it actually gives the chart a little bit more room for that 7 to have showed up. And I even look at, say, the x-axis, and notice it automatically kind of does this x-axis down here. Looks kind of funny to me, since it really kind of starts and stops before the histogram starts and stops. So I can do this same thing with my x limits. Watch maybe here if I go from x lim equals, let's say I want the x-axis to go from 55 all the way up to 80, maybe some multiples of 5. Let's see how that changes. Oh, that's kind of nice. See what happened to the x-axis there? It went from 55 to 80. The y-axis went from 0 to 9, so I control that with x-lim and y-lim. Maybe I went a little gnarly there all the way out to 80. Maybe I can do it again and stop at just 75. And it looks a little nicer. And this way it kind of gets, you can see here my x-axis down here gets to actually take up the whole horizontal axis. Are we done? Almost done. One thing you do notice about these histograms is that right here it's in the number of students, the frequency. If I want to change this to instead of the frequency to the relative frequency, or the proportion of students in each category, or the percent in each category, I can use this line, this code, prob equals true. PRB, like probability, equals capital T for true. And when it does that, why did it do that? I know why it did that. Do you know why? All I added there was prob equals true. Well, I still have this piece of code here that says y limits from 0 to 9. The only problem here is if I look at percentages, proportions, it looks like my highest proportion was 0.14. So maybe instead here, watch this. I'll take the same line of code I just had, and I'll change this to y limit, so the maximum y value is 0.2. And this will get the whole histogram back on here. And now instead of, okay, I need to change, this isn't number of students anymore, it's proportion of students, but you can see what happens here. I change this into percentages. I can do all these same attributes with my box plot. For instance, if you just see what I copied and pasted here. This is a box plot. This is of the seconds of the. These were the people running the 100-yard dash. Looks like this is what we had before. So if I want to add some stuff to this, I can. Looks like I added my Y label here, so it was time in seconds. So that's nice. And in the next line of code, I think I just kind of widened it out. I kind of said, well, let's see here. Thought this looked a little funny, just going from a little under 11 to a little over 12 and a half. So what did I do? I changed it so the Y label went from 10 to 15. Why not? It's your world. It's your happy little world. You get to create it. And didn't look like I did it there. Y lab 10 to 15. This is y lab 10 to 15. It should be y limit 10 to 15. Hopefully I would have fixed that already by the time you got this code. And if not, I'll fix it right now. There it is. So I changed it. Kind of takes this out of proportion, a lot of white space up above 13, 14, 15. But again, I'm just showing you that you could do all these same functions. Okay, I'm going to skip dot plots. This is going to be for your reference on how to make dot plots if you so choose to. So just use this as a reference on dot plots. Last part here, and then we'll get to the homework assignment, is just, well, what do I do with this graph when I'm done? It's actually super easy. I can just copy and paste these graphs into, let's say, Microsoft Word, and I just selected it and I hit Command C. Hopefully you can do it too. So it looks like nothing happened again, but let's say if I go to my to a Word document, and maybe this is my homework assignment, for instance. Watch how I can just go in here and paste now, and there is my graph that I just might have had to enter for my homework. And then I can just grab the corner, resize this. Just a little bit of advice too, I'm not a big fan of Microsoft Word. It kind of does everything for you. I just pasted this directly in, like into a line. What I don't like about this is I can't drag it anywhere. I can't move it. So one alternate way, like if you're doing your reports, go to a text box. If you go to a text box, create a text box, then go inside the text box and then paste it. I'm going to show you kind of what this does here. You see it's cut off. Watch what happens if I grab my text box and make it bigger. You see there's the whole thing. Now I want you to actually see two things really closely here. I can select the picture, and the picture is stored inside the text box. Or I can go just outside, and you see how the border got wider. Well, that's my actual text box. When I have the actual text box, like the border of the text box selected, now I can copy this, now I can hold on to it, press enter and drag it and move it wherever I want in my document. And this is going to be especially useful when you make your projects, because you want to kind of put these in nice looking strategic places. So I did want to just show you that. I just, in general, the moral of the story is I recommend actually on Microsoft Word copying and pasting these images into text boxes, and then you can grab the text box and move the text box wherever you would like. Okay, so let's try one of your homework problems here. So number one, we sampled 20 students and asked them about their favorite movie genre. 8 say comedy, 4 say action, 3 say romance, 3 say drama, and 2 say horror. So part one, create a vector using the frequency of each category, and I'm just going to skip to part B, and then use the names function to add names to each category. Okay, so here's what I'm going to do. I'm going to create a new list, and I'm going to call it movies, and I'm just going to store the numbers right now. So 8 people said, forgot what it was, comedy. Yeah, 8 say comedy, 4 say action, 3 say romance, 3 say drama, 2 say horror. So 8, 4, 3, 3, 2, and hit enter. And just if I wasn't sure, this is stored correctly. So I just did part A. So I'm just going to copy and copy this, paste it right into my homework. So there's that. Okay, now use the names function to add names to each category. So I'm going to go back to R, and I'm going to use names. What am I naming? The list movies, and equals, and I have to use my C function because I'm going to end up putting 5 different names. Now in order, the first 8 people liked comedy. The next 4 people liked, remind me, action. And then the next people liked romance. Oops. comma goes outside the parentheses, and then the last two categories were drama and then horror. And notice too, I'm capitalizing these. I want to capitalize these, make these names look nice, because this is the one that's going to show up. These are the names that are going to show up on the chart. Let's be nice and capitalize the movie genres. So if I wasn't sure, let's check this, movies, see what happened, and there that is. Now once I've done that, making bar charts and pie charts is going to be pretty simple. So there's my code for that. All right, create a basic pie chart of the data. Just a basic pie chart. So let's just do pie of movies. Okay, and here's what I want you to do for these, when you have to make a graph, I want you to first copy and paste what code you're using. So that's that, and then go ahead and copy and paste the image. Now, as I said, we're going to copy and paste this pie chart. Check it. I'm going to make a text box, and you know what? I could even just put it here in the side for now. Let's go back and find my pie chart. There it is. It's just a basic one, so this is fine. Copy. Let's go back to my Word. And paste. And yeah, it came out a little small, but if I want to make it bigger, I can. Why don't we first make the text box bigger, and then look inside here, and then we can drag this a little bigger there, and then I have to select my text box again. And okay, if I did that and that happened, you see I actually wasn't dragging the text box, I was dragging the actual picture. So if I Command Z, undo, this will go back in the text box, and then I have to find, you see how there's like two boxes? Get that outer one. That is your, yeah, that's your, there we go. That's your text box. Now I can move this around wherever I want to. Okay, last one here I'm going to do for you. Customize your pie chart by giving it a title and using your own colors. Alright, so I got to give it a title here. So let's go back here. So it'll be pie movies. Add a comma. Main equals, let's call it favorite movie genres. And then maybe the colors I want to use. C, don't forget to put all the colors in a list C. Maybe I want to use orchid. And then what were some fun colors again? Goldenrod. Excuse me. Salmon. Two more colors. Oh, and I capitalized orchid. I don't want to capitalize the names of the colors. Two more. I'm gonna get boring and use red. And then lastly, let's go aquamarine. Aquamarine. Yeah. And wherever my pie chart went, ooh, hey, it works. There it is. I'm going to copy and paste it. So let's see here. This time I didn't do it in a text box, and you can see how huge it comes. Sorry. Just make it a little smaller and you'll be fine. And I can just go right before it, and then I'm going to go back and copy and paste the code that I used. And there it is. And where'd my Word file go? Ta-da! Okay, students, I hope you enjoyed this lesson. I hope you got something out of it. And you've wasted a perfectly good hour. No, it wasn't a waste. Okay, guys, thank you. Happy studying.